We've seen a lot about designing interfaces for classes, but you all are entry-level programmers. You're not going to do that right now. Instead, you're going to focus on the easy part. You're going to be given this complete interface of the class, and you're just going to be filling in the code in each of the bodies of all the methods in order to make sure that that interface is satisfied. Okay, I say easy. Yes, okay, there might be a lot of methods. And as we've seen with function definitions, not all method definitions are all that easy to implement. But all I'm saying is that all of these skills that you've developed for implementing a function from a function specification are going to completely carry over when you are implementing a class from a class interface. So let's talk about how we might just implement one method for a class definition. Because if we know how to implement one, then we know how to implement them all, and that's all we need to do in order to implement the class. So when we're implementing a method, we first start off by, well, we look at the parameters and their preconditions, and we make sure that we assume that the preconditions are satisfied. We could check them, but we don't have to. The key thing is that if the preconditions are violated, well, that's not our responsibility, and we shouldn't have to take that into account in our code. In addition, we're also going to assume that the class invariant, the invariance of all of the attributes, is also satisfied. Because if they're not satisfied, that means that the object is corrupted, and well, that's also not our responsibility, just like, a violation of precondition is not our responsibility as the definer. Making these two assumptions about the preconditions and the class invariant, now we're going to write the code for implementing that method according to its specification. So it's just like implementing a function. Oh, except for one more detail. It's possible when we were writing the code to satisfy the method specification that we might have accidentally violated a class invariant. If that's true, we need to, at the end of the method, make sure that we fix this, clean this up somehow, because when the method is done, all of the invariants for all of the attributes must be satisfied. Now later on, when you're using the class, you should always make sure that when you're calling the methods, that you're never calling them in such a way that violates the precondition. And if you're changing an attribute, you should never change the attribute in such a way that the invariant is violated. But that's about using the class. We're just talking about defining the class. And for right now, we don't need to worry about those steps. So let's go look at a concrete example. Over here, inside Atom Editor, I have this class called time. And if we scroll down, we'll notice that in this version, well, I have some stubs for my methods. I haven't actually implemented them yet. So let's go look at this. I have the initializer, and the purpose of the initializer is to fill in the attributes for, say, my hour and my minute. So normally what we do is, in this case, is, unless we have reason otherwise, is we just copy over. So self hour is going to be equal to hour, and self min is going to be equal to min. All right, there we go. Now, of course, as I said, one of the things we have to worry about is the class invariant violated here? Because look, I have made changes to the attributes. And anytime that I make changes to the attributes, I'm worried that, okay, the invariants are violated. But let's look at this. Notice that I have these preconditions here. And I say, okay, hour is between 0 and 23. And minute is between 0 and 59. And if I look at the invariants, wow, they're exactly the same thing. This is not a coincidence. This is actually done on purpose. Because they're the same, this means that I can copy from the parameter to the attributes, and I can be sure that the attribute invariants are still satisfied. So I don't actually need to do anything here. Yes, I could add some assert statements here in order to enforce the precondition, but that's not necessary, right? Asserts are always optional. The key thing is here. And I have done everything that the initializer has asked me to do in the specification, and I have done it in such a way that the class invariant is not violated. Okay, let's go look at one more example. Here I have this method increment, and what it's going to do is it's going to move the time into the future. So I'm given minutes and hours, and I need to add those to my time. So I'm going to say, okay, I'm going to take the minutes, and I'm going to add to the minutes the number of minutes, and then I'm going to take the hour, and I'm going to add to the hour the number of hours. All right, if we look at that, I have now technically satisfied the specification of this method. I've taken the minutes and hours, and I have added that to my attributes, so I've added that to the time object. Oh, but I have a problem. Look at this. So I'm adding to the minutes, And remember that my invariant says that my minutes have to be a value between 0 and 59. So I have potentially done something bad here, right? So when I am implementing a method is not enough to satisfy the specifications of the method. I have to do it in such a way that the class invariant is not violated. All right, so I'm worried, by the way, that the number of minutes could be greater than 60. So what am I going to do if that is the case? If that is true, well, what I need to do is I need to define it up into hours and minutes. So let's go figure out how many extra hours that's going to be. So I'm going to take the minutes, I'm going to divide it by 60. And now what I need to do is I need whatever minutes are left over. I need the minutes to roll around. So that's going to be the percent or mod operator. So I'm going to do percent 60. Oh, okay, well, so wait, extra is hours. So that means I need to go add that to the number of hours. Oh, but now hours also has to be between 0 and 23. So I can have a problem if the number of hours is 24 or more. So once again, I need to sort of roll this over using the percent or mod operator. And I don't need to carry anything because I don't actually have anything higher than hours. Okay, now I'm done. Because not only do I satisfy the specification, but I have all of this code here to make sure that my attribute invariants are satisfied at the end of the method. And you might look at this and go, yeah, but didn't you just violate the invariants of the object? Well, yes, I did, but not in a way that mattered. So let's go look at this in the Python tutor. So here I have my time object. I'm going to define the time class, and I'm going to create a time object which is 1 minute before midnight when our assignments are typically due. I'm going to create the folder. And so now t is my object. And now I'm going to call increment on t, and I'm going to increment this 2 hours and 15 minutes into the future. So let's construct the call frame. Now I'm going to add 2 to minutes. And look at this. Minutes is now 74. I have now technically violated the invariant of this object, right? And as we've said many times, right, violating invariants is bad. Well, here is a case where you're allowed to violate an invariant. You are allowed to violate an invariant for an object that is in the parameter self, not in any other parameter, because self is the primary object that is being controlled by this method. And this is important. While it is okay for you to violate it, you must fix it before the method is done. So let's go step forward. And notice that I'm pulling out the 1 extra hour, and now I have changed that 74 to 14. So I'm okay. I'm no longer violating it. Now I'm going to add to the hours. Well, the hours are 26. Now I'm violating it, but that's okay. I'm going to go clean this up. That is changed to 2. Now the call frame is done, and I have erased. And now when I look at the object, it is still the case that the class invariant, the invariants of all of the attributes, are satisfied. So once again, it is okay for you to violate the invariants of an object in the parameter self, so long as you clean up after yourself when you're done. And this, by the way, is the only difference between implementing a method and implementing a function. So all of those skills that you've developed in the course up until now, you can use this when you are implementing your class.